Good morning, everyone. I am Pranab, HOD Department Economics. Now I am going to discuss one important topic, statistical distribution. It includes various types of distribution. Various types of probability distribution is more important. So, to grasp the concept of distribution, first you have to know what is probability. That is most important. So probability, so you see probability is probability of actually we use the word probability, we use the concept of probability every day in our everyday language. Every day we use the word probability in various perspectives. For example, the probability of sunshine is this much, the probability of rain is this much, like that. Now, in pure statistical terms, probability means statistically probability of anything. Probability of, let us suppose A, probability equal the number of successes divided by total number of possibilities. That is probability. Total number of success. For example, let us suppose there are 10 balloons. There are 10 balloons in a particular wall. Three balloons are red. 4 are yellow and 5 are yellow and 2 are green. So if we want to select, let us say by chance randomly we want to select one of the balls, then probability of red ball will be number of successes. So how many red balls are there? 3 red balls. So it is 3. Now what is the total number of possibilities? Equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 10. It is 3 by 10 or 0.3. That is 30%. This is the simple definition of probability, statistical definition that is. And we always denote probability by P. You always denote probability by P. And another important thing, probability of non-occurrence. It is generally that can be regarded as probability of failure. So that is denoted as Q. So the important thing is that Q is always 1 minus P. That is most important. Another important thing is obviously P plus Q will always be equal to 1. So anything, it will occur or it will not occur. So if the probability of the chance of occurrence is 40%, chance of non-occurrence is 60%, that is 0.4 plus 0.6, that is 1. So the point is that, another point, the probability always lies between 0 and 1. So probability 1 means there is 100% chance of a particular event occurring. 100% chance. We are sure and certain that the particular event is going to happen. So for example, let us suppose all balls are red. In this case, all balls are red. 3, 4, 5, 6, 7, 8, 9, 10. All balls are red. So what is probability of red ball? What is the probability of red ball? It will be 10 by 10. It is equal to 1. The other extreme is probability is equal to 0. So what is probability equal to 0? 0 means there is no chance, there is no probability of that particular event occurring. For example, in this particular wall, there are 10 red balloons. Therefore, probability of drawing a blue balloon, it will be how much? 0 by 10, that is 0. We are 100% sure that blue in any case. So that is probability, the main concepts of probability. So once you know probability, we can go to what is known as distribution. Statistical distribution. So statistical distribution can be of two types, mainly can be of two types. One is discrete frequency distribution, the other is probability distribution. Not discrete actually, observed distribution and probability distribution. So what is observed distribution? What we actually observe, that is observed distribution. For example, let us suppose there are 30 students in a class. There are 30 students in a class, and one exam was these 30 students appeared in a particular class exams, and the total mark was 50 in that particular total mark was 50. Now, after the evaluation of the answer scripts, we get the marks obtained by the 30 students. So we write down the marks. Let us suppose out of 51 students, 25, 29, 37, 44, 49, 09, 10, 19. In this way, there will be 30 marks. There will be 30 marks for the 30 students who had appeared in that particular exams. The question paper carried total mark of 50. So this is, we have observed this. We have observed this marks obtained by these 30 students. So this is observed distribution. This is observed distribution. But there are certain distributions. In case of which we don't observe the actual values. It is very difficult. In fact, impossible to denote various observed values for the values taken by the variable. In that case, again we have probability entering the picture. Here, probability enters the picture in case of distribution. For example, let us suppose we throw a coin. 50 times. We throw a coin 50 times. So what is the probability of head? When we coin the toss just one time, so probability of head is 1 by 2, because head is 1, possibilities are 2, head and tail. So it is 1 by 2 or 50%. Now, if we, on the basis of that, we can say that if we throw the coin, let us suppose 60 times. We throw the coin 60 times, then the number of times in which head might occur statistically will be 30, that is 50%. But probability is involved here. We cannot be sure and certain that out of 60 times there will be 30 occurrences of head. So this is not observed. This is probability distribution. This is not observed distribution. This is probability distribution. So we use different types of probability distributions to analyze different sets of problems which we generally encounter. Again, in case of probability distribution, you see, we still have probability distribution. in case of probability distribution, we shall have two types. One is discrete probability distribution, and the other is continuous probability distribution. One is discrete probability distribution, the other is continuous probability distribution. In case of discrete probability distribution, you have to go through two things. One is binomial, and the other is Poisson. And as far as continuous frequency distribution, continuous probability distribution is concerned, the particular distribution which we are concerned with is normal distribution. So these are the three probability distributions you have to go through. Discrete probability distribution, continuous frequency distribution. And discrete are two types, and continuous you have to deal with one type of continuous distribution, that is normal distribution. Now the question is, what is the difference between discrete? What is the difference between discrete and continuous? Very simple. In case of discrete, the values which the particular variable can surface generally comes from one integer to another. The variable can take only integer values. There cannot be any decimals. For example, let us suppose there are 100 families in a particular flat. Now, we want to undertake a particular study of those 100 families. So, and that particular study pertains to the number of children those 100 families have. So, the variable is number of children. Now, you have to give. So, number of children, how many children? Number of children. So, number of children, no children, 1, 2, 3, and let us suppose maximum 2. In that particular family, in that particular flat, we have 100 families and they have children, number of children as shown by this. Let us suppose no children, let us suppose there are 3 families. They have no child. 3 families have no child. 1 child, there are 15 families. 2 children, there are 44 families. 3 children, let us suppose 28 families. And 4 children will be so this will be the total will be 100. So this is discrete frequency distribution. So number of children, it cannot take values like 0.25, 1.25 or 2.35, etc. It jumps from 0 to 1 to 2 to 3 to 4, etc. There cannot be any values in decimals. So this is discrete frequency distribution. On the other hand, in case of continuous frequency distribution, the difference is that the variable can surface any value. That is why we have class interval in case of continuous frequency distribution. For example, 0 to 5, 5 to 10, 10 to 15, 15 to 20, etc. So, that particular variable can surface any value. 2.75, 2.95, 8.75, 8.28, 8.69, 10.75, etc. So that is continuous frequency distribution. So in case of distribution like this, probability distribution like this, we either use binomial or Poisson. On the other hand, if the distribution is of continuous type, then we go to what is known as Poisson. We go to what is known as normal distribution. We go to normal distribution. So you see, binomial means there are two possibilities. One will be success, the other will be failure. There can be only two possibilities of a particular experiment: success and failure. That is why the name is binomial. On the other hand, Poisson distribution, actually Poisson distribution is a limiting case of binomial distribution. When number of occurrence n, let us suppose n is very high, then it is a case of Poisson distribution. Actually, you have to first know the forms of the various types of distribution. As far as binomial distribution is concerned, it is like this: probability of r is equal to NCR p to the power r q to the power n minus r. So it should be obvious from the earlier examples that P is probability of success and Q is probability of failure. N is total number of experiments, total numbers. Small r is number of success, number of success. This is binomial. This is binomial distribution. As far as Poisson distribution is concerned, it is probability of r. It is equal to e to the power minus m to the power r divided by factorial r. So, to solve the problems which are concerned with these types of distribution, we have to know the concepts of combinations as well as this factorial. Factorial r, what is NCR? These concepts you should be very clear about. And as far as normal distribution is concerned, actually there is no straightforward formula for solving the various types of normal distribution. In case of normal distribution, actually many people find normal distribution very hard. The concept of normal distribution very hard. But I suppose that normal distribution is the easiest of the three things. Normal distribution is easiest of the three things. So to know normal distribution, you have to first know what is known as the normal curve. What is known as the normal curve? What is known as this is the normal curve. This is known as normal curve. What is the speciality of this curve? The particular variable is normally distributed. That means the curve will be like this. Now, in case of normal distribution, we convert the x variable to what is known as z variable, and z variable is x minus mu divided by sigma, and sigma is what is known as standard deviation. Sigma is known as standard deviation. So in 1 class, it is very much impossible to cover all the things. I am just throwing light on the salient features of the three types of distributions. So in this case, what Z distribution implies? Z distribution implies that the entire population has been subsumed, has been brought under this particular normal curve, and we assume that the particular value is normally distributed. Actually, in economics, most of the variables are normally distributed. What is normal distribution? For example, let us suppose heights of the teachers of Darrang College. Let us suppose heights of the teachers of Darrang College. So you see, so average height will be highest. So average height will be highest. Let us suppose 6 feet 5 inches. So this is average height of the teachers of Darrang College. And at this point, Z will be equal to 0. Again, there will be 50% here and 50% here. So 50% will be the heights of 50% will be less than 65 inches. On the other hand, height of 50% will be higher than 6 feet 5 inches. So teachers with the highest height, let us suppose this is 6 feet 1 inch, 6 feet 2 inches, let us suppose. So here 2 or 3 teachers will be there. Here 2 or 3 teachers will be there, like Ranjan Mishra, myself, Sanjay Dekha, etc. Similarly, this is the lowest extreme of the distribution, that is left hand side. So here will lie the teachers with the minimum of heights. The teachers with the minimum of heights. And this is the average. So now I have given the example of teachers of Darrang College. Let us suppose the number of soldiers in a particular cantonment. In a particular cantonment, there are 1,000 teachers, 1,000 soldiers. Another important point is, the information is given that the heights of the soldiers, average height of the soldiers are 5 feet 8 inches. 5 feet 8 inches. That is 68 inches. 68 inches. And standard deviation is, let us suppose, standard deviation is 2.5. Now on the basis of this information, we can use the normal distribution. To find how many soldiers are more than 6 feet, how many soldiers are less than 6 feet, how many soldiers are less than 5 feet 5 inches, etc. And very accurate information will be given. So the entire group of 1,000 soldiers will lie in this particular curve. So where this average will be 5 feet 8 inches. 5 feet 8 inches. Here we said that 5 feet 8 inches. 5 feet 8 inches. 5 feet 8 inches. After that, we shall find out the z variables for different heights, which we are asked to find out. Let us suppose we are asked to find out how many soldiers are above 6 feet. So what is the z variable for 6 feet? 6 feet is 72 inches. So z variable for 72 inches will be 72 minus 68 divided by 2.5. So let us suppose it is here. This is the z variable. This is the z variable for x is equal to 72 inches. Z variable. So we have to find out this. How many soldiers are above 6 feet? And how many soldiers are less than 6 feet? The entire region plus this one. That will be less than 6 feet. How many soldiers lie between 5 feet 10 inches and 6 feet? Let us know this is 5 feet. This is 5 feet 10 inches. So we have to find out. this. this reason will give us the probability of soldiers having heights between 5 feet 10 inches and 6 feet. So we have to go to the normal table. There will be one normal table with different probabilities. We have to go to the table to find out the exact figures. So for today, this much is, I suppose this much is enough. So you try to go through these things in the book, B.Sc book, and you can, if you have been able to grasp the topics, then it will be very much easy for you. And after that, I shall go to inverse frequency, that is Bayes theorem and other things. Thank you.